All right, AP, here's sample exercise 2.85. We're naming various types of compounds. So before, we would only work with type 1s, only work with type 2s, only work with type 3s, only work with polyatomic ions and compounds. And so you are practicing using the exact same naming strategy. Here you're going to have to identify which naming strategy you use for each particular problem. Same idea here, 2 tasks. 1, give the systematic name for each of the following compounds, and 2, given the following systematic names, write the formulas for each compound. Go and press pause now, because here come the solutions. All right, for the first one, P4O10. There are 4 phosphoruses, so I need to say tetraphosphorus. There are 10 oxygens, so decoxide. This is a binary covalent compound, so that makes it type 3. So that's what indicates that we need to use the prefixes. Now, one thing that is printed in this particular version of the answer, that anion is, it's not an anion, I'm sorry. The oxygen there, it's written here as decaoxide. That's not a steadfast, hard and fast name for that. The vowels that follow those prefixes, like tetra or deca, even nana, octo, those are often dropped. Now, sometimes they're not, okay, and I'm not going to nitpick about that. So if you use decaoxide, that's fine. You'll probably hear me say decoxide. So just be aware that that's in the works. We have NB2O5. This is a type 2 binary compound because niobium is a transition metal. Okay, and so that tells us that it's going to need a Roman numeral to indicate the charge. How do I know what the charge is? Well, oxygen always forms a -2 charge, and if there are 5 of those, that's a total of 10 negative charges. And that has to be perfectly balanced by these 2 niobium ions. If there are 2 of them producing a total of plus 10 charge, that means each individual niobium atom ion is contributing 5 charges, total of 5 charges. So niobium 5 oxide. We go to Li2O2. This is a little bit of a tricky one. This is a type 1 binary compound containing lithium ions, but also has peroxide ion. Yeah, this is not a dioxide situation here. Peroxide is something that happens only with main group 1 metals. When you have 2 main group 1 metals and 2 oxygen atoms, here it's 2 lithiums and 2 oxygens. What happens here, there aren't enough electrons in the metals here to actually form the normal charge that oxygen would form. Normally, it would form a -2 charge, and since there are 2 oxygen atoms, that's a total of -4. So that would be 4 electrons being taken from the electron source, the metal here. But in these particular cases, with all the main group 1 metals, there's only 1 valence electron per atom. So for each of these lithiums, there's only 1 electron available. So because there's only 1 valence electron, group 1. So since there are 2 of them, there's a total of 2 electrons available. So even though that oxygen does ionize, it does not form each individual O-2. It forms an O2 with a -2 charge, and that's a peroxide ion. So this is lithium peroxide. D, TiNO34. Okay, so that's titanium and nitrate. Now, titanium is a transition metal, so it's going to require a Roman numeral, but how do I know what that Roman numeral should be? Well, the anion, it's a polyatomic ion, that's nitrate, and I see from my polyatomic ion sheet that it forms a -1 charge. How many are there? There are 4 of them. So there are 4 -1 charges. That's a total of -4. And so the 1 titanium ion needs to supply that positive charge. So it's titanium 4 nitrate. Let's get to number 2 here. All right, being given names, and we are producing formula. So vanadium 5 fluoride. Vanadium is going to have a plus 5 charge, so they're going to need to be 5 negative charges, and fluoride is going to be yielding that, and so I need 5 fluoride, so VF5. B dioxygen difluoride. I'm seeing prefixes here, so that tells me this is a covalent bond. It's going to be a molecule, and no ions here, so type 3. The prefix di in front of oxygen indicates that there are 2 oxygen atoms, and the difluoride indicates that there are going to be 2 fluorine atoms, so O2F2. C, rubidium peroxide. Again, rubidium is a main group 1. Okay, main group 1, so that means each rubidium atom only has 1 valence electron to contribute when it ionizes. And so even though there are 2 oxygens here, there aren't 4 electrons available to fully ionize both. So you only get like a partial ionization. Well, I mean, it does ionize, but it's only, each oxygen is only getting 1 electron. So an O2 for oxygen here is only forming a minus 1 charge. Oh, sorry, minus 2 charge. My bad, minus 2 charge. Gallium oxide. Gallium is a main group 3, so like aluminum, it only forms plus 3 ions. Okay, so that's a plus 3 ion maker with an oxide, a regular old oxide this time, not a peroxide. So that means that oxide is going to form a minus 2 charge. There are 3 of those, okay, 3 oxygens, so it's going to be a total of minus 6. And the 2 gallium, the gallium needs to balance out that minus 6 with a plus 6. Well, gallium only forms plus 3s, so you're going to need 2 of those gallium atoms to fully make up for that minus 6 charge with a plus 6 charge.